Hello and welcome students to the lesson on surface areas and volume of a right circular cone. So these are the following objectives that we need to understand regarding this video class. So first we can start with how we can define a right circular cone, then derive the formula to find the surface area of a right circular cone. Then further we can derive the formula to find the volume of a right circular cone too. And further we can discuss the applications of these formulas in which we can apply to various situation-based problems to find the surface areas as well as volume of various conical objects. Okay, so let's begin with the very first one, that is a right circular cone. So here you can observe that we are having two 3D objects. One is a pyramid and one is a cone. So we'll discuss briefly that in what ways they are differ from each other and in what ways they are similar. Okay. So as you can observe that pyramids and cone usually sometimes they look similar to each other because the reason is they are having one common base. Okay, and their lateral surfaces join at a common vertex at the top. But the difference is the in the nature of their bases. In the nature of their bases, as you can observe that a pyramid is having a flat and triangular lateral surface, whereas a cone is having a curved surface, right? So if you look at the bases, okay, so pyramid's base is of a square shape and that of a cone is of a circular shape. So we can note that the bases of pyramids can be any polygonal shape. Okay, it can be a rectangle, square, triangle, or a pentagon, etc., depending on the type of pyramid. Then now coming back to the cone, so it is a solid with a circular base and a curved lateral surface. Okay, which is having a common vertex at top. So next, what we can see that how a cone is constructed. So what we can take. So let's take a right angle triangle in which we are having the perpendicular height as h and radius as r as the base. So if you can see that this triangle is rotated quickly along one of its sides, then we can see that this type of figure is formed, which is a right circular cone. Okay, so the side along which the triangle is rotated becomes the height of the cone itself, and the secondly, one of the two sides becomes the base radius r of the cone, and the third remaining side, which is known as the slant height L of the cone, which is actually the hypotenuse of the right angle triangle. So as you can see that the difference between the height and L is the height which is perpendicular to the base of the cone, okay, while the slant height is not perpendicular to the base of the cone. So now using Pythagoras theorem, what we can see that we got a relation between L, R, and H as shown over there. So we got this relation, that is L is equals to under root of R square plus H square. So one more thing we can note that if height is perpendicular to R, then in that case, we'll see that such type of cones are called as right circular cones. And if height is not perpendicular to the base or the base radius of the cone, in that case, we are not having perpendicular. So that will not be a right circular cone, right? So now let's take a practical situation in which, for example, you have to make 100 conical shaped hats for a party purpose. Okay, so how would you estimate the material required? Okay, so if you know the area of one conical cap, you will be able to find the area of 100. Okay, so let's try how we can make how we can find the area of one conical cap. So that will be equal to curved surface area of that cap plus area of the base. But in case of a cap, as you know that it will be hollow from the bottom, so we'll be not having a solid base in case of a hat. So we have to just find the curved surface area if we need to find the area of a one conical hat. So let's see how we can find the CSA of a hat. So basically, the formula, as mentioned previously, also total surface area or TSA of a cone, that's equals to curved surface area CSA plus area of the base. So in this case, we have to just find the curved surface area now. So to find the area of the cap, we need to find this CSA only, that is a curved surface area, and let's see how we can find that. So here is a sample of a conical shaped hat. So if we cut along its slant height, so and open that, so this shape will be formed, okay, as shown in the figure over here. So the straight edges represent the slant height L, and the curved edge, as you can see, represents the edge of the circular base, that is nothing but 2 pi r, okay. So the length of the curved base, that will be equal to 2 pi r, okay, which is mentioned over here, as you can see, where r is the radius of the base. So now what we can do, let's divide this base into as many triangles as possible. And the CSE of the cone, that will be equal to the total area of the triangle. Okay, CSA, that will be equal to total area of the triangle. So area of each triangle will be calculated as half into base into height. So in this case, what we can see that the height is same as the slant height L of the cone, and base, at the place of base, what we can see. So let the base be B1, B2, B3, and so on for all these triangles that we cut out from this curved surface. So the total area of the triangles can be calculated, can be calculated as shown over here. So now taking half and ls common, what you will get, the total area of the triangle, that will be equal to half into slant height into sum of the bases, right? So now the sum of the bases will be equal to 2 pi r only. Okay, so now we can substitute that over here. So that's the curved surface area, or the lateral surface area of a cone, that will be equal to pi r l, where r is the radius of the base of the cone and l is the slant height. So next we can discuss the area of the base also. So the area of the circular base, that will be equal to s pi r square. We already know this from cylinders. Okay. Now taking pi r as the common factor. So this formula for TSA of cone can be written as pi r l, which is the curved surface area, plus pi r square, which is the area of the base. So if you can take pi r common from here, so you will get pi r into l plus r. Okay, now let's move to the concept of finding the volume of a right circular cone. Okay, so let's take a practical example. So let's see how the volume of the cone is calculated. Okay, so consider a cylinder and 4 cones, right? So, and one thing is given, that the radius and height of these cones and cylinder should be same. The radius and height both should be same in case of cylinder and cone. Then what we'll do, so cylinder is completely filled with water on any liquid. So let's empty the liquid into the cones. Okay. So what we'll observe, that the entire content of the cylinder can be emptied into 3 cones, not more than 3 cones. So exactly 3 cones we can fill from that cylinder, provided that the height and radius should be same in both. The height and radius should be same for both cylinder and cone. So it is a practical example that you can check as a practical activity also. So what you will observe, that volume of a cylinder is equals to 3 times volume of a cone. And our previous video class, we already learned that how we can find the volume of cylinder, that is nothing but pi r square h. So we'll just substitute the value over here. So volume of cylinder is equals to pi r square h, that is equals to 3 into volume of the cone. So volume of the cone, from here you will get that 1 by 3 pi r square h. Okay, so that's the final formula to find the volume of a cone. So in today's class, we got 4 formulas. Okay, the first one was for slant height that we discussed, that was under root of h square plus r square, slant height of the cone that we can use to find the radius as well as height as according to our questions. Then second formula we got for curved surface area, that is equals to pi r l, and third formula we got for TSA, that is equals to pi r in brackets l plus r, and not last but not the least, this one is the final formula in case of cones, that is about 1 by 3 pi r square h, and that is nothing but the volume of the cone. So provided that the cylinder, the volume of a cylinder is equals to 3 times the volume of cone, provided that if the height as well as the radius in both the cases should be same. So that's all for this session about cones, and inshallah we'll try to solve some uh, uh, problems based on this in our coming Zoom session. So till then, that's all from my side in this video class. So thanks a lot for watching this video, and try to practice the questions on your own, and we'll discuss more in our coming sessions. So that's all from my side. Assalamu alaikum to all of you.